a very good evening and a warm welcome once again to all our guests, architects, engineers, students, and key partners who have joined us today online and on ground for our fourth webinar series on the UltraTech IndiaNext initiative for 2022 Build with Speed. Our past three webinars have proven popular with active participation from the construction fraternity across the nation. Professionals, students, designers, consultants, and even end users who are seeking inputs on technological and material improvements for building a home have graced our session. Our speakers in the past have been Mr. S.J. Vijay, whose topic was on ready-mix concrete to ready manufactured buildings. Dr. Anil Swani, who spoke on disruptive technologies, equipment, and processes. Mr. Amit Burde, whose emphasis was on precast initiatives. These live webinars have not only helped us to connect with our stakeholders, but have also helped us to reach to the newer generations of architects and engineers who are constantly seeking rich content and newer methods in technology advancement. The insights that we have received through the webinar have helped spur ideas and discussion amongst our IndiaNext competition participants and also triggered conversations leveraging speed in the building and construction sector. As a thought leader, India's #1 cement, UltraTech, has always been at the forefront of such initiatives. Ladies and gentlemen, in today's webinar, in spite of it being a Friday in India, we have had more than 3,000 participants who have joined us online and another 1,000 more who have gathered offline. I'm still getting the numbers, they're pouring in as I talk. More and more participants have come onto this webinar to listen to our speakers. Given the intriguing topic, we have already received a huge bunch of questions, and I can't just tell you the number of queries and questions that have already started popping up, and it's really resounding to see that the engagement is tremendous from all of you, and I'm really glad that you are so participative in the session today. To give you enough of time for your questions, I will want to dedicate the last 15 minutes of our sessions so that all of you all can get answers to your queries. Because of the number of questions, we will have to put a hard stop at 8 p.m. India's time. But please keep on pouring your questions. I know in the past, most of you have written to us that you have had unanswered questions. We don't want to leave you in that situation. So please keep on pouring your questions, and we will try our best to have all your questions answered. Okay. So for the benefits of the speaker, I will try and give you a heads up at 5 minutes before 8 o'clock so that our on-ground audience get their questions answered. Okay. Thank you very much, and keep those questions coming. Moving forward, and without taking much time, it's now time to invite my very first guest for the evening, Mr. Ajay Dang. Ajay leads the marketing function at UltraTech Cement and is responsible for formulating the product and marketing strategy, strengthening the premium positioning of brand UltraTech, and driving profitable growth on the portfolio. He is an award-winning marketer and was awarded Marketer of the Year at the International Advertising Association Leadership Awards in 2016. With a rich exposure across sectors from FMCG, consumer finance to media, Ajay has led many award-winning marketing campaigns. Under his leadership, UltraTech has bagged Advertiser of the Year, Brand of the Year, and Marketer of the Year awards this year, along with 60 plus national and international recognitions. He has a proven record of delivering strong business results in tough competitive markets through strategic thinking, strong execution, focus, and innovation. Let's put your hands together for Mr. Ajay Dang.
Thanks so much, Roshan. I'm so delighted. As you all know, this initiative is an initiative where we gather all the technocrats, the policymakers to discuss key issues which are facing the nation and the solutions to some of them. I'm delighted today to welcome two eminent guests that we have and sharing with us a fairly innovative technology stuff. This is one area, construction is one area which has deluded automation for the longest period of time. And this technology, I think, seems to be the right one, possibly poised to provide that solution and fulfill that gap. Please, along with me, welcome Philip. Philip is the co-founder and head of Americas at Cobot International. Cobot is a leading supplier of 3D construction printers with activities across 6 continents. Cobot has recently built about a 190 square meter house, the largest 3D printed construction out of real concrete in the capital of Oman, Muscat. The house was printed in 3D printed in 2 phases. In the first phase, a team of local workers was trained in the printing process. Then they did the whole printing themselves. The project took just 5 days to complete and had substantial cost savings. Welcome on board, Philip. Also, I'll welcome Simon. Simon also co-founded Cobot in 2017. Simon is an experienced engineer and has demonstrated history of working with mechanical and industrial engineering industry. He is skilled in CAD, sales, mathematical models, SolidWorks, and management. In 2019, the company produced and delivered the largest 3D printer in the world to Saudi Arabia. Welcome on board, gentlemen, and look forward to hearing lots of fabulous stuff from you. Over to you, Philip.
Thanks a lot. Simon, maybe you pull up our presentation here so we can get going. First up, we want to say thank you to UltraTech for organizing IndiaNext. We were very, very pleased when they reached out to hear if we wanted to present today, as knowledge sharing within the field of 3D construction printing is of utmost importance to us. We also want to say thank you to all of you, thousands of people that have joined in today. It really shows to us that there is a lot of interest around this topic, and we cannot wait to present to you today and also attend the Q&A session, which I think will bring a lot of good discussions. Quickly about me and Simon. Well, we're both co-founders of Cobot International. We're the world's leading manufacturer of 3D construction printers. I recently, not recently anymore, I guess I rejoined a year ago after having been a consultant with McKinsey & Company. And then Simon, maybe you present yourself.
Yeah, sure, Phil, thanks. So my name is Simon, and I've been co-founding Cobot as well. I've been here since the very start of Cobot when we printed the first house, which we are going to show you later on as well. Before that, I've been working mostly in the AM sector, so additive manufacturing and printing in other sectors, which has given good knowledge to this field as well. So looking very much forward to speaking at this event. Thank you for having us.
Thanks. Yeah, and today we will be speaking about how 3D construction printing is changing the world of construction. Before we get into it, we want to just quickly show you, because some of you might have seen it before, some of you might not. But let's have a look at how exactly that looks. So here's a video from our partner Perry and minority investor Perry, and they're setting up a printer here in Germany, where they're building a 3-story home, 3D printed, 380 square meters, you can see there. It's actually in 3 floors. So it's a really big 3D print that's going on. It might just be on my screen here, but the video is chopping up a bit. It doesn't really matter, but you can see how the video really shows that the layers are put on top of each other using concrete, which gives you this final structure that real people can actually live in. So it's quite fascinating, and it really demonstrates that construction is ready to enter the future. Let's quickly see here what we'll talk about today. So first, a quick introduction to Cobot and our 3D construction printing technology. Secondly, we would love to showcase to you which kind of projects have been done using this technology. And then number three, we want to discuss more theoretically what are the benefits of actually using 3D construction printing and what will be the future of it. And then lastly, of course, 15 minutes of Q&A. Let's quickly jump into Cobot. Cobot was founded, as mentioned in the beginning, in 2017. We're based out of Copenhagen, Denmark, but we're actually establishing 3 new offices this year in the United States to cover North and Latin America, in Dubai to cover the Middle East and Africa, and then lastly in Malaysia to cover Asia Pacific. So really expanding across the globe. We are 80 employees right now, and if you turn back time just 12 months ago, we were just 30 employees, and a year before that, just 9 employees. So we're really growing a lot, and that also shows in our sales numbers. So we've actually sold now almost 40 3D construction printers worldwide, including to India, and we sold our first printer in 2019. So it's a tremendous growth trajectory that we're on. I should also mention about Cobot that we have a very strong minority shareholder in Perry Group. So those that don't know, Perry Group is a very large manufacturer of formworks equipment and scaffolding equipment, and it's a worldwide company. So we're very, very happy to have them in our group. Now, Cobot does 3 different things. Number one is we develop and we manufacture and sell our own 3D construction printers globally, and you'll see just how global we are in just a sec. Secondly, we cooperate with world-class companies across the globe in actually bringing this technology to life. So, for instance, that would be GE Renewable Energy, Perry Group, Larsen & Toubro, whom you all know, Emaar Group, who built the largest building in the world, the Burj Khalifa, etc., etc. So, really strong companies that utilize Cobot technology to enable 3D construction printing. And then lastly, we and our partners do a lot of research within the principles of 3D construction printing. How do you do good reinforcement? How do you print slabs, et cetera, et cetera? And also a lot of research within the material science itself, for which we collaborate with a lot of great universities and cement and concrete manufacturers. Moving on. Here you can see our global footprint. So we're basically based all around the globe on 6 different continents. You can see there's also a flag in India, and we're bringing way more printers to your region. Our footprint is not only broad geographically, but also in terms of our clients. So we have construction companies, we have R&D institutions, cement and concrete manufacturers, precast plants, et cetera, et cetera. So it's really wide, not only in the applicability of this technology, but also in terms of the geographical footprint. If we move on, here you can see our sales. So last year we sold 22 3D construction printers, making us bigger than the rest of the industry combined. And this year we expect to sell at least 40 printers. So we're really moving ahead, and this technology is ready to take on the future of construction. If we go ahead again, Simon.
Yeah.
Simon, why don't you take us through how the technology works?
I would be delighted to, Philip. Thank you. So let me tell you a bit about how our technology functions. So we have a XYZ gantry 3D printer. It's a modular-based system. From the beginning, when we started speaking with customers, we figured out that depending on the projects that customers have, the size of the machine needed differs a lot, right? So we made a modular system from the get-go, our Bot 2 construction 3D printer, which has exists of 2.5 meter modules in X, Y, and Z. So in X length, you can go up to 12 meters. You can go unlimited in the Y length. You can just put on extra Z poles. And in the height, you can go a bit above 8 meters. We can actually go a bit above 9 as well with this installation if you put it on concrete feet. So on the side of the machine, you can see we have a concrete batch plant. And this allows for the machine to use locally sourced material, sand, gravel, and cement. With just a little bit of additives that are supplied by us, we can then print directly with 99% local material. So on the right-hand side, you can see an on-site installation of the technology. and where it's printing in the bottom. I just want to quickly show you, we have just developed this for World of Concrete, the biggest concrete fair in the world in Las Vegas here in January. A configurator that actually explains a lot about our technology and makes everybody understand kind of where we are. So I want to switch quickly here to the configurator. I have to say this is also an Android app and iPhone app. So those of you that want to play with this afterwards, either go to your browser and go to our website. Otherwise, you can play with it on your phones. So the idea here is to kind of give you an idea of how our system works. You can see we have the X, Y, and Z of the printer. You can choose how many modules you want, and you will be seeing directly what sizes you can print here. So we can put on the build volume, for example, this version, which is 464 modules, can print you 3 stories with a floor plan of 140 square meters. We also have, so you can see how the technology functions. I'll show you the first printed house in Europe here. You can actually put in different buildings. We have a library of different ones where you can see it printing. So just speed it up to a little bit quicker speed here. You can see how it all functions. So at certain print speeds, you can also get an output time. This house will take 8 hours approximately to print and use approximately 8 cubic meters of concrete. So this is quite a fun tool. Be sure to look at that later.
And while Simon brings up the presentation, I can say it's not as choppy when you actually use it. It's because the internet connection, when streaming to so many people, makes it a bit laggy. But back to you, Simon.
I'm seeing it all fluent on my screen because it's running here locally, right?
Yeah, exactly.
Good to know. Good to know. Yeah. So let's jump into some of the 3D printed structures that our technology has done with different partners around the world. This gives a good picture of what the technology can really do. So to kick that off, I just want to show a selection of, this is just a selection, I have to say, of the projects that have been done with the countless machines we have out there. And these are kind of the firsts in the world that made headlines along the 3D printing and construction media. So we have alongside the first building in Europe, 2-story building in Europe, 3-story building in Europe, 2-story building in India. And then also with GE, I think it's interesting that we did the first windmill tower because this is not a house. This is showing that this technology can be used in other areas, like what EPCs are doing as well. Residential building in Europe, in Germany, also buildings in Africa, buildings in Florida. So you can see we have a wide reach of good customers using our technology to head the way for the technology. So let's jump into the first. This was actually the first printer we ever sold. It's for a research company called Camp C in Belgium. The interesting part about this, not only was it the first second or 2-story building in Europe printed ever, it also was printed by students, which is really, really interesting. So basically, our guys came down and taught a group of students how to operate the machines. Those students would then teach on to the next students so they could kind of collaborate on making this house. So it took 21 days to print. The total is 90 square meters, and we just have a little video here. Might be lagging a bit if the rest is also lagging, but I think it shows kind of an interesting point, which is we have the slab, and then when they start printing the walls, you will see that they actually experimented with different kind of infills inside the walls. Because bear in mind, this is still a new technology. There's lots of research to still be done on different things, and these guys have been interested in kind of learning how to make these structures load bearing. I'll cut the movie here. You'll have plenty of time to see more printing. So going to Germany, close by Belgium, we have our investor Perry and good partner through a long time now. They printed the 2 first printed houses in Germany, and these are fully permitted houses for living in, which is also a milestone in terms of regulations. So this one in Beckham is 160 square meters in a total of 2 floors. What is interesting to look at here is both, of course, the architecture is amazing, if you ask me at least, but it also to look at the print time here. So you can see there's 2 floors. Ground floor took 28 days for them to print. Top floor took only 8 days. What we're seeing here is the immense learning curve that new technology has also. But once they gain to master the technology, everything speeds up a lot. A little video of that. You can also see that they tried to build in kind of the different amenities inside the house into the printing process. Then we have Wallenhausen project, which is a 3-story building with apartments. It's 380 square meters. They did this fairly close after the other project I just showed you. And from the learning from the first project, you can already see here they were down to 7 days per story. And these stories are a lot bigger than what you saw from the other house. Also fully permitted, so that's of course really important.
May I just add, Simon? Sorry, sorry, Asaf. If we go back, so the first project that Perry did, that was the one which is 1,700 square feet. The second one is more, or 160 square meters. The second project they did, well, they went up to 4,100 square feet, so they more than doubled the size, and they added an additional floor. However, they decreased the print time by 15 days. So it really shows, as Simon said before, just how much of a learning curve there is and how steep it is. Imagine when Perry starts doing their project number 10 or 100 even, how fast they would actually be able to do it. It's quite fascinating.
Yeah, it is fascinating indeed, Philip, and this is also showing what we want to communicate. It is a new technology, so people are learning along the way. I think if you look in the total in the world, we have less than 100 houses printed at this point in time. So just by learning, really, we can see that this technology has an immense potential to speed up the process of building. And this project is super interesting from a perspective of not housing, but other construction that you can do with our technology. So this is a collaboration with GE Renewable Energy from the US. So the idea here is to print the first meters, the first up to 30 meters of a of a windmill tower in order to gain taller turbines. And the idea here was to test out the project in a 10-meter scale model. So it's 6 meters in dia in bottom and 10 meters tall. It used 100 tons of concrete for this specific specimen, and it took us 3 weeks to print. GE were quite happy with this, but we wanted to print again. So the year after, 2020, we did the same, but this time we made it all massive. So all the holes you can see, the hollow snake structure was all in one big piece. So we upped the amount of concrete to 175 tons of material, and we finished in just 3 days. So this also shows the learning curve we're talking about. By doing projects, you really learn how to master the technology. So this is such a big focus area for GE that they even mentioned us and our technology and our collaboration on the President's Summit for Climate in 2021, which we're really happy for, of course. And then we can just see a small video here. It's probably lagging, but you can see some time lapse of the printing of the windmill tower. So quite a big project, and also quite a big teardown when we had to get it out of this hall. So I want to give the word to you, Philip, now to tell us a bit more about this Africa project.
Thanks. Yeah, so I think the last project that Simon showed us here with GE really shows that it's not just residential housing or affordable housing. There's also a focus area which is more commercial, or as in this example here, a school, which was actually 3D printed. This is done by 14 Trees in Malawi, Africa, and it took only 18 hours to print. And that gives the kids here an indoor classroom and an outdoor classroom. I think we even have a small video here covered by World Economic Forum. So you can see here the kids playing around it. It was actually very cool. All the kids they gathered around the printer as it was being set up and sort of followed through the full print length. So imagine putting a printer on a flatbed truck and then taking it around in the local areas and then printing schools or other structures that are needed by the local community. And then lastly, we want to show you a project by the same company, 14 Trees, which is an affordable housing project in Kenya. So here they want to do 52 affordable homes in Kenya. The project is called Mwele Gardens, And they already did the first of those homes, a test home in 2021 in Nairobi. That's the one there to the left. So this also shows that the technology is sort of maturing. It's no longer smaller one-off projects, but the projects are actually becoming larger, both in terms of volume of the number of units, but also the units themselves. So we can move on. Those were an overview of some of the projects that our partners have done. There's a lot more that they have done, where we can't cover them all today, but we're happy to discuss further in our Q&A, of course. Lastly, we want to talk about the benefits and the future of 3D construction printing. So why do we do all these projects? Why have our partners decided to actually invest in this technology? Well, we see four main reasons for that. Number one is automation. You reduce the labor cost. The second one is speed. You can do structures faster by 3D printing. Number three is sustainability. You only print what's needed. You reduce the waste. And number four is design freedom. It opens up so many new doors that wouldn't have been possible before from a cost perspective. So let's jump into each one of these first. So if we start with automation, why is automation needed in the construction industry? Well, McKinsey & Company did a report not too long ago stating that more than 50% of activities, almost 50% of activities in the construction industry can be automated. It's one of the least digitized and automated industries in the world. Secondly, there is a major lack for skilled labor all across the globe, meaning that projects, the prices increase and it takes longer, they get postponed. Thirdly, the rising cost of materials. Steel, lumber has increased immensely in value all across the globe. This is why cost and automation is an important factor. And then lastly, there is a global shortage of affordable housing. In the States alone, the estimates is around 4 million homes. Now, if you do that worldwide, the number is really staggering. This is where automation and cost reduction can help. So speaking of cost reduction, how does it actually look like from a practical level? Well, the cost addressed by 3D construction printing differs from what type of structure that you're doing. So if you're doing, for instance, residential housing, well, here we say that around 30, maybe to 45% of the cost is being addressed by 3D construction printing. I'll show you an example of just that in 5 seconds. But if we go down the list here that we've shown, well, if you do a school, you're addressing more of that share, more of that cost share. For instance, a school doesn't have a kitchen. And that means that a school like the one we showed you before, there you'd be printing the walls, right? But you won't have that kitchen, which also is a cost factor. So the addressable share really increases all the way down to, say, a wind turbine tower base that Simon showed you, where that's 100% concrete if we don't take into account the steel reinforcement. So the overall message here is that it really differs from construction to construction project. If we just go into residential housing, here we've done a breakdown of that 45%, which is being addressed by the 3D construction printer. So for instance, you can print the foundation, you can print the groundwork. That's around 10% of the cost of a home. Remember, these are global averages, so they might differ from region to region. Secondly, the raw house structure itself. Here we're thinking around 1/3 of the cost is being addressed. That would be the walls, reinforcement, the roof, etc., etc. But however, there are some areas, some elements that cannot be addressed. For instance, the finishing or the surfacing. So the doors, the windows, if you do painting, you cannot 3D print all of that yet. And then lastly, the other costs that cannot be addressed by 3D construction printing. For instance, insulation, heating, or ventilation, plumbing, all of that that has still to be done with conventional methods. That's why we say around up to 45% of the costs can be addressed. That's not to say that you save 45%, but that's to say that the total cost addresses 45%. Moving on. So how can we actually reduce costs with 3D construction printing of those 45%? Well, if we look at structures that are flat versus structures that are curved, here you can really see how that comes into play. If we look at a completely flat wall, well then the cost of of constructing it with 3D construction printing and conventional, we just call that 1x. That could be, for instance, 1,000 euros. However, if we do just one curve, well, then the cost of conventional, it actually doubles. However, the cost of 3D construction printing, it remains the same, more or less, because the machine doesn't care. For the machine, it's just a file that it spits out. And then lastly, if you do two curves to that wall, well, it's around 10x. It's 10 times more expensive with conventional. However, with 3D construction printing, cost is it doesn't really move because, again, the machine doesn't care. Moving on. Here are just some of the example buildings that were done recently by Cobot partners using our technology. So in the beginning was mentioned the project in Oman, for instance, the one in the middle. Here you can see this is around 190 square meters, and for the project itself, the total cost was less than $2,000 for 190 square meters home, and it's comparable, you can see, with the other projects. So the cost itself for the walls, potentially also the foundation and the slabs, is very, very low compared to, let's say, it would have been done with more traditional methods such as timber or brick. And in the end, this will be a very, very big factor in why these companies choose to go for 3D construction printing. Moving on.
I think I'll take over from here. Thank you, Philip. So let's look into the second one, where we look at the speed increase that we can do with this technology as well. So we just want to show you this example. So on the left side, you see the first printed house in Europe that we made in 2017. We made that house in 2 months. A lot of learnings. You can see the machine. That was our very first installation of one of our technologies. It took us 2 months and used 20 tons of concrete. After we built our second generation machine, we figured, why not do this again? So in 2019, just 2 years after we made the first house, with all the learnings we made throughout those years and our new technology on hand, we tested the print again. What we saw was that we did it in 3 days, so 28 hours of printing time in total, spanning over 3 days. So we did some sleeping there as well. But if you look at these gains, it's quite interesting, right? It's more than 20x in terms of time. And this is what we want to show as well, that it has a huge potential in terms of really speeding up the process of making walls faster. I think we actually have some videos, but I tried to mitigate these a bit because of the lagging. You can also see the quality here of our first house was not up to par what we can do today, at least.
We did a lot of research back then, let's put it that way.
Yeah, I mean, we learned so much from this, which basically made what we are today. So it was, I mean, a very, very groundbreaking project at that point in time. So I'll just jump over here so you can see the second slideshow. I think that's a bit more interesting. So this shows the second print we made with our second generation Bot 2 printer. This is the same technology we are selling today. You can see the counter in the front of the video showing the time of the time lapse. More than that, the quality of the walls just looks so much better than what they did just 2 years before that. Okay, because of time, I will just cut this video again. If you want to see all this, we have a good YouTube page as well with all these videos populated. Great. So if we look at step number 3, which was sustainability aspect of improvements that 3D construction printing can do, we're mainly looking at 4 different areas. One is that you can actually make less waste. And this is quite interesting because basically when you're not casting, you can, with 3D printing technology, already accommodate for holes for windows, for electrical and plumbing. So all that material is saved because you don't have to extrude it. We're only using the material that we need for the exact build and walls. Less reinforcement, because in prefab concrete, you typically put way too much reinforcement inside to make it possible to lift it and move it to site. We don't need to do that. We are printing directly on site with our technology, which mitigates the excess reinforcement. Then material efficient design. So Philip told you about the form freedom that we have with our technology, which really taps into this, right? So before you only did square houses because that was the only cost-efficient thing to do. Now we can actually look at using the forms to mitigate material usage as well. And then new materials, of course, super interesting point. We used, for example, 23% recycled roof tiles in the pod building that you saw just before. It could be other filling materials and so on as well. There's even a lot looking at more green cements, which I think that the host of this webinar also knows a lot about. So if we look at just the topology optimization, so in reducing material for a certain size of building, we had this case which actually taps into 2 schools in Africa, as we talked about earlier, where the material cost is really one of the driving factors for the cost of the full building. So the idea was to get the same square meterage out of less material. And by doing round forms, you all know that you're actually gaining more area per surface area of walls. So with 204 square meters of floor space in this new design, we're using 11 cubic meters of concrete. In a conventional design with classrooms that are of the same sizes, but in a square design, you use 12. So that's around 10% of material saved. And in some markets, 10% material saved means much more than 10% in price reduction, right? So super interesting point as well. Then over to you, Phil.
So just to recap what we've said so far, there are 4 benefits to 3D construction printing. We went through automation, we went through speed, and now Simon just took you through the sustainability aspect. Now, the last aspect is actually one that all of the architects listening in today will find very interesting, I think, which is to say the technology really allows it opens up so many doors for doing things in new ways. That's why we at Cobot, we say you should not use technology of the future to replicate solutions of the past. And we'll just give you a few examples of that that are not even related to 3D construction printing. The first one is a bridge. It was done almost 250 years ago in England. It's called the Iron Bridge. It's 100 feet in the span, so around 30 meters. This was the first major bridge made out of cast iron, so it was a very new material to be used for this application back then. However, the way it was used, the way this new technology was used, they basically replicated solutions of the past. How? Well, they did these joints, which are called dovetail joints. You can see there to the right how they look. Those joints were known for from the timber industry. So you would actually take wood joints and create them like that. However, they took the new material, and replicated past solutions. And that really led to an increase in cost. It added more complexity, and the bridge was not as strong as it could have been. So if we fast forward 100 years to the Eiffel Tower, well, here you also used a fantastic element, steel, and now they have learned how to actually use the future technology to create new things by creating the Eiffel Tower, which is 11 times larger than the span of the bridge. So the Eiffel Tower was actually the largest structure in the world for 41 years. And you can really see that was accomplished by taking the steel and putting it together in new ways. In essence, they were not replicating past solutions. Another example, if we move on. Another example would be to actually create things that conventionally would be way too expensive to do. And one example of that is printing wavy patterns as part of the wall. So Simon, if you play the video, now again, it's a bit laggy here, but you can see how the printer really creates this beautiful design simply from a 3D file. And there in the front, you can even see we 3D printed our logo as part of that print. And again, the cost of this is the same. If the wall had been flat, it would have been the same cost because the printer doesn't really care. So the conclusion here is really to say, how can we take this fantastic new technology and think outside of the box? So those are the 4 key benefits of 3D construction printing as we see it. Moving on. Those benefits are great. What does it mean for the future of the technology and the future of construction? Well, we might be biased, but we really see that 3D construction printing will take the industry, will take the construction industry from one S curve to the next. Construction is, as mentioned earlier, one of the least digitized and automated industries in the world. However, what we see now is that with all these benefits it brings, you're really pushing it, you're pushing construction to the next level. And we see three key drivers of this, how to increase adoption. Number one is there will be a lot of improvements in the technology alone. As you see with mobile phones or any other technology, well, every year there are improvements to it. So 3D construction printers will increase in speed, the reliability will increase, the material mixing will be more consistent, etc., etc. And then, of course, we will also see that new features will be added to the printers, which is something we will announce a lot of great things in the coming years. I cannot speak too much to it right now, but those will be happening, taking construction printers really from being just 3D printing to multifunctional construction robots. The second driver of adoption is the scale. So Simon showed you before that the structure done with GE Renewable Energy, the wind turbine tower base, was 10 meters tall. Well, we're implementing and we have developed and recently delivered a printer to GE, which is able to print up to 20 to 25 meters in height. It's staggering. It's 6 to 7 stories in height done by this machine here. So it's a really, really big piece of equipment. And we're going to see more and more of these big machines being deployed all around the globe. And then the third driver of 3D construction printing for increased adoption is really the development of new use cases. So what if the printer could be used to be printing, for instance, underground? Can you print a basement or a pool? What about more commercial applications such as garages or warehouses, logistics centers, hotels? There are so many areas that are yet to be explored besides just residential affordable housing. So we see the future being very, very bright for 3D construction printing. So if we move on, in essence, this is how we see it. When the PC was introduced, when the laptop was introduced in the 1980s, along with the mobile phone, they really couldn't do that much, and it was only a few people that actually owned them. However, fast forward a few decades, all these products are ubiquitous. There are so many new features that were introduced. They're super fast, they're super reliable, and you couldn't imagine your life without them. That's not to say that we think that every person in the world will own a 3D construction printer, but at least we know that this technology will go in that direction, where it will become something you'll see across the globe being used in construction as any other piece of equipment being used in that industry. So if we move on, I think that was it for our presentation part here. We would like to say, before we enter the Q&A, we would like to say a big thank you again to UltraTech for organizing IndiaNext, and we want to say thank you for listening in to all the thousand that has joined us here today. Thanks a lot, and we look forward to discussing more with you now.
Yeah, thanks a lot.
Thank you so much, Philip. I think that was fascinating, and I think there are audience questions in plenty, but I have a ton of I think ones buzzing in my head as well. So before I do that, I'll just please invite my partner in crime, the gentleman who explains all science, which is tough and difficult for me. He is Mr. Jaishankar. He is the Senior Vice President at UltraTech. He is a civil engineer by profession, more than 25 years of experience in the cement industry. He's been, I think, working across many companies on the basic premise of making concrete better. He chairs and is been leading a lot of professional engineering organizations across the country. And so welcome, Jaishankar. Philip, I was fascinated by, I think, some of the examples that you did, and I think was very intrigued by the first piece that you put across is that I think oftentimes we we don't rethink the use cases and possibly are retrofitting the future technology into the past, and that was fascinating. In fact, I remember, I think horsepower coming and people being named as cars being named as horseless carts when they had first come. And we need to kind of rethink. What are the key areas, do you think, Philip and Simon, where we need to, I think, fundamentally rethink how we do construction? That's one piece. And from an India perspective, where I think the scale and the speed that we require and the urgency of the problem is massive, what are the first few things that I think engineers, architects in India should attack? What problems, what are the first low-hanging fruit that we should, I think, attack with the 3D printing?
Do you want to take the first one, Philip? I can take the second.
Sure. And I believe the first question is how should construction be rethought? Is that correct?
That's correct, Philip. Given that we don't want to fall into the same trap that I think people in England fell into while making bridges. So what do we do which is different? And India has a habit of leapfrogging technologies.
Exactly. So I think with any new technology like 3D construction printing, it's important that deployed to and as many people as possible get the possibility to see it, to touch it, to be involved with it, and actually use it. Because that's when you get a lot of people together, they get all the good ideas, and that's how the technology is improved. That's how you discover, well, why don't we do more curved walls like this? Or how if we did we print logos as part of it? Or how can we decrease the width of the walls in order to reduce the cost of those buildings to make it cheaper for people to live there? I think doing stuff like we're doing now, this event here, where everybody gets to learn and sit together and discuss, is super important for any new technology. So I would say that's the first one: bringing people together, letting them try it out.
Yeah, I totally agree with you, Philip. And also, I mean, just to keeping an open mindset. So the configurator we made is exactly about the same thing, right? It's a way that you can get acquainted with the technology without owning it. This is also why we are very delighted to speak on events like this to really get the word out about the technology. But open mindsets are super important, and this is the same in all AM industries as well, metal, plastic, whatever. You have to think in new ways.
Yeah, I think you've got to allow more people to play with the new technology. That I think they'll find more use cases. Yeah, wonderful. Thanks so much. Jayshankar, do you want to take the first question from the audience?
Yeah, sorry, I didn't think we answered the second one of your questions. I can just quickly do that.
Yeah, please. My apologies.
You asked about the low-hanging fruit, right?
Yeah.
You asked about the low-hanging fruit. I mean, I see a big potential in low-income housing, smaller homes of not that big size. I mean, if you deploy our machine in a certain size, you can build multiple homes at the same time. So getting to master this technology with speed, as you saw before, in our immense increases in speed, then those houses will be very, very interesting to look at, and also built in materials that will last a lot longer. So I think affordable housing is a big thing.
Wonderful. Thanks, Simon.
Of course.
Yeah, Simon and Philip, very informative and very excellent presentation. Thank you for that. And I think definitely the architects and engineers would love it, because you told about one axis curve, two axis curve, why not three axis curve? So that is the way the people want from the linear this thing to curves. They are liking this thing. One question was there, that whether India will get ready when for this adopting this technology. Already 2 buildings have been constructed, one in IIT Madras, one 3D printed house is completed, and L&T has also done in one Kanchipuram, where I think you have given the printer for them to do that.
Correct.
So basically, when you go for this 3D printing, there are 2 challenges. One is the printer is one part, and second is the matrix what you are using for printing. So this should gel together very well so that we can have it. The first question about the printer is, suppose I want to construct a 1,000 square feet house. What are the factors we should see while selecting a printer?
So for it was a 1,000 square meters to square feet house.
Square feet house. Yes.
Square feet. Okay.
Yeah. So in essence, the thing about our technology is that it really allows for a lot of use cases, not only in terms of how small or how big you can go, but also in terms of materials. So let's say you're going for a 1,000 square feet home. Well, our system is actually modular, meaning that we allow our partners to try out very, very small scale printers, which then can later on be extended in all dimensions once they once they become more comfortable with using it. So you're not really restricting yourself in any sense. You can start off with a small printer that can do just a few meters by a few meters. And then once you get more accustomed to it, then you can increase in size. The second thing I mentioned there was about materials. You also mentioned that before, sir. And again, our machines are fully open source. So we know that construction is it's a very local industry with local strong suppliers of cement, sand, gravel, and concrete. So that's why we say we allow our machines to be open source. They can use concrete, they can use mortar. By all means, our clients can use chocolate to print with if that's what they want.
Okay. And there are a lot of questions on how we are going to give reinforcement. There is still a doubt whether reinforcement can be given or this thing, and what are the challenges when using this printing when reinforcement is given.
Yeah, so reinforcement is one of the big discussion points on this, of course, because you have a layer by layer technology. So we are targeting it from a couple of different perspectives at this point in time. So most of our customers, what they do is that they actually print columns. So you print hollow structures, which basically acts as the scaffolding or the mold for a cast column. In that cavity, after you're done printing, you can then insert rebar as you usually do, and then cast it out. What this makes it possible is that you can actually target normal building codes even today, right? Because columns, everybody knows how to calculate on. Funky 3D printed structures with 2 axes of curves, people are not so acquainted with that in terms of accepting building codes. So that's the far most seen solution to reinforcement at this point in time. So printing hollow structures, typically with an inner wall, and then casting out with rebar inside.
Okay, thank you. A lot of questions on how the slab is casted. Is it done with 3D printing or separately the slab is casted, the roof slab?
Sure. So Simon, if you have our presentation from HolsterPro, we have a lot of documentation showing this. And while if Simon can find it, then I can explain it verbally in the meanwhile. So in essence, one of our clients, actually from Denmark, they 3D printed the roof slabs for a student housing unit, which is around 40 square meters, 4 hours away from Copenhagen. The way you do it is, in essence, on a construction site, you would start off, you would put up the machine, and then you would print the slab. So you would basically print the perimeter of that slab, and then once that's cured, you would put in concrete and rebar. You would pour that. Now, then you would lift that to the side using a crane. While the slabs are curing to the side, then you would print the walls where the printer is standing. And once the walls are there, then you would actually move back the roof slabs on top of it. And you can actually see here this presentation, the 5 steps. Simon, if you go back just one, the 5 steps page. We're not sitting in the same room. I'm actually visiting some of our clients in Ireland. Simon, there's a page with 5 steps.
Yeah.
So here you can see you start off by printing the boundary of the print. Then you put in reinforcement. You put in a filigree solution. We overdid it a bit here. There's a bit too much steel, but nevertheless, it's very strong roof slabs. Then you cast the concrete down around the first 7-8 centimeters, which means that there is a bit of that steel which is still sticking out from the concrete. Now, once that has cured, then you can actually place it on top of the building, on top of the 3D printed walls. And then finally, as step 5, you do the final casting. So these guys here have really done a tremendous job. Our clients from Copenhagen. 3DCP Group is the name.
Yeah, and the beauty about this is that you actually print the slabs before you start printing the house on site. You pull them to the side, they let them cure. Meanwhile, you're printing the walls, and they will be ready for when you have to apply them.
Philip, one of the thoughts that, and maybe it's a silly question on my part, I think, and just building on a couple of comments and couple of questions per se, is there potential that I think you do 3D printing plus precasting, and that I think sorts a lot of the construction issues. It gives you design flexibility, it offers speed, and I saw in your presentation also as to how the learning curve, once I think are done, it just you can accelerate the learning curve in terms of printing times almost. So is that a possibility? Is that experiment that you guys have done, or is that something in the works in progress?
So just to clarify, are you meaning using our technology as prefab?
Yeah. No, the thought was that, yeah, its thought was that I think there are pieces that you are very good of. I think there is time in terms of setup on location and so on and so forth, which is the tricky bit from a 3D printing perspective. But the speed, the form, the shape, and those are strengths. I think if you combine both these I think phases, it might have a win-win and might sort out a lot of negatives of both the technologies.
Sure, and that's the thing, that's definitely possible. There might be use cases, there might be different projects where it makes sense to 3D print some of it, and some elements are done off-site prefab. That could definitely be the case. What we've seen now, however, with our customers is that they really want to go out and test the technology, be on site, and utilize all the benefits. But I'm sure that in the future, it will be, there could be definitely be cases where the two are combined. Right now, you also saw in the video in the beginning that there are still a lot of conventional trades involved with 3D construction printing. For electricians, professionals that do kitchen, you still have to do the landscaping, the roofing in some projects, etc., etc. So it plays together nicely with the conventional trades. It's not replacing everything from one day to the next.
Okay.
Wonderful. Jayashankar, you want to take the next one?
There are a lot of questions on how much safe it is with regards to earthquake. Is it earthquake resistant? Any studies on this?
Yeah, so I mean, basically, this comes a lot up to material, right? There's two parts of it. There's the material, and there is the way you build. So we've done tests with our 3D printed concrete. You might think that it's actually delaminating because you can see the layers, but it is all one structure when you cut it up. It is all homogeneous. So you can compare it to a normal concrete of the same mix that you would cast. So what is really interesting here from my perspective, at least, is that in earthquake zones, why don't we start using the form freedomness and the design freedom to actually design better for these kinds of problems? You can do wavy patterns to get more tensile, stuff like this, right? It's something that has to be looked into, but I just see more potentials than problems, to be honest.
One question, as far as I think the construction codes and regulatory bodies are, I think, fairly, to use the pun, rigid, right? Because it's safety that's concerned, and I think new technology has to pass through that entire phase. Any work that you guys are doing and is there an industry body which is, I think, on 3D construction or 3D printing? They're working towards framing some of those norms and working with regulatory authorities across the world.
Yeah, so a very important question. The big problem here is what you also said in the end, across the world. I mean, it's very different from country to country and area to area what codes are present. And because this is a totally new technology, it's also harder to get accepted, right? So what you see right now is that people are using these column structures to cast out normal columns. So basically the 3D printed walls, even though they are probably 4 times stronger than brick if you calculate, still they use the 3D printed walls as kind of the environmental shell, you could say. And then the columns will be the structural elements of the building. However, we are looking and working with different universities and regulatory bodies to test and get the technology accepted, right? Another thing is that, I mean, printing with one material here in the far north with 6 degrees of centigrade or printing in your area is also a bit different and will have influence on the material, right? So it's for sure something that there's a lot of work in, but there's ways to circumvent it already today to get approvals fast with the comms, for example.
Yes, I mean, because I think some of the piece, I think while you're talking about the technology, I think I just referring to and Jaishankar can comment about it a little more. I think the matrix, I think oftentimes cement and cement code and concrete codes, those are regulated. And I understand this would require a very different matrix depending upon the application, and therefore standardization becomes a bit of a challenge, and therefore regulation even more kind of stuff. Is that a challenge that we are facing?
Yeah, of course. I mean, this is one long game, right? But again, as I said in the beginning, we have ways to already get buildings accepted right now, and the more we see also from competitors, ourselves, all our partners around the world doing new houses, we have more and more proof that the technology actually works, which I think will make it a lot easier. I'm not myself into the regulatory part, but I know we are working on it as well. But meaning that we get it accepted in Europe doesn't mean that it's necessarily accepted in India, for example, right? So there's a lot of work to be done. And we are focusing mostly in Cobot International on the technology, so to increase our output and reliability of the technology. And then all partners are also working with this problem. So yeah.
There is a lot of questions on the thickness of the wall also. Yeah, about the thickness of the wall, what you are constructing. And also one more question is whether any ultra high performance strength concrete is used to reduce this thickness.
Yeah,
sure. On the thickness, it's important to state that we can have very, very thin walls. Let's say you want to do 5 centimeters, something like that. But you can also have very, very wide walls depending on how much strength you really need. So a typical home here, we usually go for 5 centimeter walls. But for very, very large projects, say the one with GE Renewable Energy, the wind turbine tower base, of course you need something much stronger. So here the print head itself, I believe, Simon, was it like 20, 25 centimeters or something like that?
More than half a meter.
More than okay, so there you go, right? Very, very wide nozzle heads that we're using. It basically just means that you would have to pump more material through in order to accommodate.
Yeah, it basically just means that we have interchangeable print heads, so whatever you need in terms of thicknesses, we can accommodate that.
Yeah, and to your point, Simon, that also means, of course, you get a lot of flexibility and a lot of control over your cost and your waste, because if you go for very, very narrow walls, of course, you reduce the material cost and it's better for the environment. So you really have that flexibility. With regards to ultra high performance concrete, again, we're fully open source. So for something like the GE wind turbine tower base, that had very, very strong concrete, right? Whereas for the conventional homes here, we're usually talking around 30 to 35 MPa. It's really up to the user how strong or how weak or which level of strength they are going for.
Yeah, what would be ideal? I think if dream come true for this technology to go through, and I'm sure you've thought long and hard about the bottlenecks that are there, which stand in the way of, I think, actually commercializing and large scaling this thing. What would be, I think, the dream come true and the first big bottlenecks that you think should go out?
So from my perspective, I think in terms of bottlenecks, we just have to see more. I mean, this is a new technology, right? We are a 4-year-old company. We've sold 40 machines as of today. By far, we are the ones that sold most. So what this technology really needs is to see more. More real-life printing, more use cases. I think that the business cases are already just around the corner, a lot of them. So utilization and adoption are really key in these times. Anything to add?
Right, thanks. Jaishankar, do you want to?
Yeah, there is a lot of question on, a lot of question on the mixed design for this making this metrics. Basically, they want to know the factors which affect this thing. Some of the factors like pumpability, printability, buildability, then maybe the open time. All these factors. So a lot of questions on how we should do a mixed design considering all these factors. Anyway, that the mixed design experts has to answer that question.
Yeah, I mean, we would love to go deeper in that also on a separate call at some point, maybe. But basically, it is very complex, right? You need a material that's very pumpable. We have long hoses. You need a material that stands totally when it comes out of the nozzle, doesn't change shape. And you need a material that's active once the next layer comes over to get the right adhesion, right? So it is a tricky material, but I think with the experience we've gotten through all our partners and the last 4 years of research, we are pretty much there, and we can help everybody of our customers getting to print in their climates as well. So we have different additives from our side that can be utilized to make normal concrete pumpable and printable, which only accounts for 1% of the total volume of material. Quite interesting, because we see, and as Philip has stated multiple times, we need to be open source for this technology to gain adoption, right? If we had to send the materials out from Denmark to all around the world, it would simply be stupid, right? So we are very open in terms of that. Also, we have two very good PhDs in material science here that helps all our customers get going.
So there are a lot of questions from students also. Some of the students are doing the PhD in this topic. Some students are asking when you are coming to India, so that we are like we would like to work along with you for this technology. And some people want to do the research, they need help, whether you can help them to get this research in the 3D print.
Sure, very happy to hear that as well. And as head of Asia Pacific, I would be delighted to talk to anybody who are interested in our technology for your region. We are seeing more adoption in your region in terms of people wanting to buy the machinery. Hopefully, we'll see some university and research institutions as well at some point in time. I will be coming to India myself also to do a speak in September at the Additive Manufacturing Association. But please feel free to contact me on LinkedIn or by email. We would be happy to collaborate.
We can also give Simon's number away, and then we could have 1,000 people call you.
It's not the number, but email is all good.
Yeah, I think we are running. I think just to contain enthusiasm and questions, this Friday evening, and we are running short on time. However, Philip, before you joined, and we were talking earlier during the day with Simon, and my first comment to Simon was, after having seen the technology, I think you are on the wrong continent. And I think India is where the use cases and the scale of you go where the problem is the largest, I think, to solve, and where I think people leapfrog and take a technology and leapfrog existing technologies far more. I think we've seen that in case of India with technologies like mobile and that. So I think, yeah, you're coming to India in September. Maybe I think you'd like to accelerate your visits far more, and I think gather some partners. We'd love to host Philip, you and Simon. Wonderful, and thanks a lot. I think it was a really enriching presentation. Preston, you want to so thanks on behalf of UltraTech and all the technocrats and policy people who are there on the call right now. If I hope I could send across, my phone's been buzzing. I hope I could have sent you photographs of where people have gathered and watching, I think, your presentation across the country. Royston, you want to say a word of thanks on our behalf?
Yeah. Thank you, Ajay. You very rightly said. I think I'll leave it to Deepak to send the photographs to both Simon and Philip, so that they understand the kind of audiences that have been gathered on ground, and the kind of questions. I'm sure those also will be shared with you. But I think thanks a lot, guys. I think very enriching session. Philip and Simon, thank you from UltraTech for taking time out for this webinar. More importantly for your support, and finally sharing with the Indian audiences this cutting edge technology and application in 3D technology for housing projects. And I'm hoping that there have been a lot of key takeaways for our audiences. Uh, Also, I would like to thank Mr. Ajay and Jay Shankar for being the voice of the fraternity today, facilitating the introductions, the conversations between our audiences, and of course our expert panelists. I thank all the audiences, architects, engineers, Friday night for taking out your time to attend this session. This webinar has surely kept up to its promise in exploring the state-of-the-art construction technologies for rapid and cost-effective construction. It has been a super buzzing evening, a super buzzing day for all of us, and I'm sure the same with you guys, Simon and Philip. And I think very, very high engaging participation. Please keep up this participation across the IndiaNext webinars that we'll keep on bringing to you for the months to go by. Okay. For those unanswered questions, and I specifically like to mention this, we will be sharing the responses on email. We will surely have the questions shared, sent across to both Simon and Philip, and hopefully we will get their response and we will have their responses sent to you. I know that a lot of people who have been writing to us stating that they want certain questions to be answered, and we will attempt it from our end. The recorded session of this webinar can be viewed on our website in the next 72 hours for those who have missed it. And I hope all of you have had a very informative and constructive evening. So goodbye, and thank you once again, guys. Thank you, Simon and Philip, for being such great speakers, and Jay Shankar for such a good Q&A session. And of course, Mr. Ajay for that beautiful introduction and that beautiful session that you've done with the team. So thanks a lot, guys. Have a great day. Have a great week, and a good life ahead. Cheers.
Thank you so much.
Thanks, everybody.
Yeah.
Thanks, Philip.
Bye.
Yeah, thanks. Look forward to hosting you soon in India.
Looking forward to that, AJ.
Sounds good.
Talk to you.
Thanks. Bye.
Bye, guys. Bye, everybody.
All right.